So these are the materials that you'll need. We have our mortar and pestle, a beaker, a glass stir bar, a graduated cylinder, and a container of water. In this case we have deionized water, DI. These are our sediment cores taken from the locations that you guys may or may not have already been to. These were taken from the exact locations where the wells have been drilled. These are the sediment that's in the place where the wells were. From these cores, we have taken samples of sediment. You can see we've labeled it, right? This is from Laguna Salada, well 1. It's from 0 to 5 feet. That's the length of core that we're talking about. This was taken at 4 feet down from the surface, and we collected 2 inches of sediment. That looks like this. So we dried the sediment to make sure that it was nice and dry, but you can see it's clumpy. It's stuck together. So I'm going to use that mortar and pestle to gently break apart these clumps of sediment so they are loose grains again. Okay, so now I have unclumped my sediment. I did my best to not overly pulverize these grains. I don't want to break up anything. For example, if there was a seashell, I don't want to shatter it. I just wanted to unstick them from these big chunks to this more looser grain material that's more like what it would have been in its natural environment. Now I can't completely return it to the way it once was, so I've already introduced some air into my measurement, but I have what I can. My goal was to get approximately 100 mLs of sediment into this beaker, and so I think I've accomplished that fairly well. If I didn't have enough sediment, I would have stopped at 50 mLs, but I was pretty sure that I did. So here we are. Our next step is going to be to measure out 100 mLs of water. So now we need exactly 100 mLs of water. So I'm going to try and fill up my graduated cylinder with exactly 100. No. So that's 100 mLs as measured from the bottom of the meniscus. Okay, so the fastest way to get to where we're going, I need to completely saturate this sediment with water so that all the empty pore spaces are full of water. So one of the quickest ways we can do that, I can add water from this beaker until I completely cover this sediment. Once the sediment is completely covered, I'm going to use this little dropper to remove any excess water and return it to my graduated cylinder, this guy. And then I will know exactly how much water I've put into the pore spaces of the sediment, and therefore the pore volume of this sediment. I'm going to use this glass stir bar to agitate the sediment and make sure that it's all saturated. Okay, so now I'm going to begin removing this overlying water. As you can see, most of the sediment has cleared out. If you can tell, there is still some suspended sediment, that's why it's a bit of a murky color. But these ultrafine sediments are not going to particularly affect my porosity measurement, so I'm going to go ahead and continue anyways. Okay, now that we've removed the overlying water as best we can, we have left approximately 49 mLs. which means that we added 51 mLs to fill all the empty spaces in this sediment. So if our sediment takes up 100 mLs of space and also 51 mLs of water, then our porosity is going to be equal to the 51 mLs of water divided by the 100 mLs of sediment, which is going to give us a porosity of 0.51. Porosity itself being unitless.